Welcome back to Science for Sleep. Tonight, we're going to take a slow, gentle walk through something almost impossible to grasp: the sheer size of the universe. Not in a rushed, scientific way, but in a calm, imaginative way. A way that invites your mind to wander, stretch, and softly explore distances and scales so large they barely make sense to the human brain. You don't need to stay fully awake as we explore. If your mind drifts, that's perfectly fine. This isn't a lesson you have to memorize. It's a journey you can simply experience. A quiet exploration that lets your imagination float from one cosmic idea to the next, like drifting from star to star. Tonight, we're going to look at the universe through the eyes of an inquisitive, curious traveler, someone who loves to ask, what would that look like? And how big is that really, compared to something I know? We'll gently shrink and expand the cosmos into familiar shapes and everyday objects so you can feel the scale rather than just hear the numbers. We'll imagine planets the size of berries, stars the size of lanterns, galaxies the size of sprawling cities, and a universe so large that even imagining it feels like stretching your mind across an ocean. As each comparison unfolds, you'll be invited to picture it, slowly, softly, without pressure. Just an easy drifting from one idea to the next. Because that's the heart of tonight's journey. Not facts delivered quickly, but scale delivered calmly. Space is too vast to understand all at once, but it's wonderfully soothing to explore in small, dreamy steps. And with every step, you'll discover just how extraordinary our place in the cosmos truly is. So find a comfortable spot, let your breath settle, let your eyes grow heavy if they want to. And as we begin this long, peaceful exploration of size and distance, you're welcome to imagine, wonder, and gently stretch your thoughts across the universe. Before we drift deeper into the vastness of space, let's take a slow moment to settle into the journey. If you enjoy these quiet explorations, these long, soft wanderings through science and imagination, you're welcome to like, subscribe, or share a thought below. It helps others discover these calm, slow-paced journeys, one sleepy mind at a time. But there's nothing you need to do right now. Just breathe. Let the day begin to fade. Let the quiet of the night wrap around you. Tonight's journey is about size, cosmic size, and how a human sense of scale tries to wrap itself around distances so enormous they almost feel unreal. To ease into that, imagine your mind stretching gently with no effort at all, the way a horizon stretches into the distance. You don't need to picture anything perfectly. Just allow the images to form softly, like daydreams drifting at the edge of sleep. As we move forward, we'll begin with something familiar: Earth. Something you've seen in photos, maps, globes. Something you know intuitively. And slowly, we'll expand outward from there, step by step, comparison by comparison, transforming distant astronomical measurements into shapes and sizes you can actually imagine. Each comparison is just an invitation to wonder. You can picture it clearly or let it blur. Either way, it will gently guide your sense of scale into deeper space. This is a long journey, more than 2 hours of soft cosmic exploration. So there's no hurry. Everything will unfold slowly, with plenty of room for your mind to drift or rest. Distance, size, scale we'll explore them all gently, as if we're taking a peaceful nighttime walk across the universe, stopping occasionally to imagine something enormous shrinking down to the size of a familiar object in your hand. Let yourself feel curious but relaxed, inquisitive but unhurried. This isn't a lesson you have to absorb or remember. It's simply a place where your mind can roam without effort, following the quiet thread of comparison as it leads outward from Earth toward the unimaginable. And now, with your mind softened and your curiosity awake in a slow, dreamlike way, we can begin exploring the first familiar piece of our cosmic puzzle, the true size of Earth, and why our intuition about it is only the very beginning. When we talk about size here on Earth, we're used to measurements that feel familiar. We know what a house looks like, or a mountain, or a continent. We can walk across a room, drive across a city, or fly across a country, and every distance, no matter how large, still fits comfortably inside our everyday sense of scale. But the moment we step into the universe, our familiar understanding of size begins to crumble. The numbers get bigger, then bigger still, and eventually they drift so far beyond human intuition that they stop feeling like size at all and start feeling more like abstract ideas. Tonight, we're going to soften that difficulty by exploring cosmic size the only way humans truly can, through gentle comparisons, visual metaphors, and slow imagination. Instead of miles and kilometers, we'll use objects you can hold, rooms you can picture, and distances you can easily imagine in your mind. These imaginative translations aren't perfect. No comparison can fully capture the immensity of the universe, but they make the impossible feel just a little more understandable, like turning a distant star into something you could place on a table, or a galaxy into something you could walk across in a dream. The first thing to understand is that space is mostly empty. When you imagine the solar system, you might picture the planets sitting close together, orbiting neatly around the sun in a tight formation. But in reality, the planets are tiny, and the distances between them are enormous. If the sun were the size of a large beach ball, Earth would be a tiny grain of sand, not centimeters away, but many meters down a long hallway. Mars would be another grain of sand even farther away, and Jupiter would be a larger pebble at a distance. That feels almost comical. These images help us grasp something our intuition struggles to visualize. Everything in space is far more spread out than we assume. Another thing to understand about size in the universe is that it expands in levels: planetary, stellar, galactic, intergalactic, and each level is exponentially larger than the one before it. When we say exponentially, we don't just mean a lot larger. We mean that each step up in scale is so massive, you could fit all the sizes below it inside without even making a dent. For example, you can fit every planet from Mercury to Neptune inside the Sun and still have room. Then you can fit hundreds of thousands of suns inside the volume of a giant star, and then millions of those giant stars inside a galaxy, and then millions of galaxies inside the observable universe. The jump from one layer to the next is so enormous that it makes the previous layer feel tiny in comparison. But we're going to walk through these jumps slowly, one at a time, gently stretching your imagination. You won't need to calculate anything or memorize numbers. Instead, you'll be invited to picture shapes, distances, and sizes in a calm, imaginative way. You might imagine shrinking the entire solar system down until it fits inside your living room. And then imagine shrinking the Milky Way down until it fits on a piece of paper. You might imagine stars as grains of sand, or planets as seeds, or galaxies as floating lanterns drifting across a dark lake. As you let these images form, your mind will naturally begin expanding its sense of scale, not through force or effort, but through slow familiarity, seeing one comparison, then another, and letting each one reshape your intuition. You may find that the universe feels a little larger, a little quieter, and a little more awe-inspiring each time you imagine a new comparison unfolding. That feeling is exactly what tonight's journey is about. And with your imagination now warmed and gently stretched, we can begin with something close to home, the size of Earth itself. Earth feels enormous when you experience it from the ground. A long drive can feel like crossing a world. A flight across an ocean feels almost unreal in its distance. Mountains seem impossibly tall, and oceans seem impossibly deep. But when we step back, when we look at Earth from a cosmic perspective, something surprising happens. Our planet, with all its landscapes and continents and weather systems, suddenly becomes small enough to fit comfortably into the palm of your imagination. To begin understanding the size of the universe, we start by gently shrinking Earth down to something familiar. Imagine holding an apple in your hand, smooth, round, cool to the touch. At this scale, the entire planet, every city, every forest, every mountain range, becomes that single piece of fruit. Now picture the atmosphere. Even though it feels vast when you look up at the sky, in this model, it's thinner than the layer of wax on the apple's skin. The entire breathable layer, the protective blanket of air that makes life possible, is just a fragile film. This tiny layer is where every cloud forms, where every airplane flies, where every weather system plays out. Earth feels big to us because we live so close to its surface, but from a cosmic viewpoint, we sit on a very thin shell. To take the visualization further, imagine slicing the apple in half. Even the deepest parts of the ocean, the Mariana Trench, deeper than Mount Everest, is tall, barely scratch the surface. And beneath that thin outer crust lies a vast interior of molten rock and metal, most of which humans will never see. The enormous landscapes on the surface occupy such a thin fraction of Earth's volume that, if this apple were real, a gentle tap of your fingernail could cover the height of Mount Everest. Now imagine placing this apple on a large, empty table. Around it is nothing, just open space. This simple image is surprisingly powerful because in the scale of the universe, Earth really is just a small object sitting alone in a vast expanse. If you placed a second apple across the room and called it Mars, the distance between the two apples would already feel surprising. And yet, in reality, Mars isn't just down the hallway. It's millions of kilometers away. Even in our scaled-down models, the distances quickly start to feel too large for the objects we're using. To help make this clearer, imagine Earth as a small marble instead of an apple. Now place that marble on a football field. The sun, at this scale, would sit far, far away. Not at the next yard line, but at a place where you might squint to find it. Earth would orbit around this imaginary sun at a distance so large, that you could walk for minutes and still not reach the edge of its path. This is the first hint of what happens when we move from planetary size to solar system size. The planets become tiny, almost invisible, while the distances between them stretch out so dramatically that they no longer feel intuitive. Even Earth's size relative to the Sun is difficult to picture. If the Sun were a large beach ball, Earth would be smaller than a pea and placed far down a hallway. At this scale, you could line up more than 1 million tiny Earths and still barely fill the volume of the Sun. This comparison often surprises people, not because the Sun seems big, but because Earth suddenly feels impossibly small. We tend to imagine ourselves living on a massive sphere, but in reality, we live on a world that is closer in size to a speck of dust than to the colossal star that warms it. And yet, this tiny speck holds everything we've ever known. Every human emotion, every memory, every story that ever unfolded happened on a world small enough to shrink into your hand. Understanding this doesn't make Earth feel insignificant. It makes the universe feel vast. It sets the stage for the journey ahead, where each step outward transforms our sense of size again and again, gently stretching our imagination to match the cosmos. When you look at illustrations of the Earth and the Moon, they're usually drawn far too close together. A bright blue planet on one side, a pale grey moon just a little off to the right, as if you could reach across a small gap and touch them both. But the real distance between Earth and the Moon is so vast compared to their sizes that most diagrams simply can't show it accurately. Our intuition imagines them gently orbiting close together. Reality places them far apart, connected by a gravitational pull that spans a stretch of emptiness too large for simple pictures to capture. To understand this more clearly, imagine Earth again as an apple sitting in your hand. Now shrink the Moon down until it becomes a small marble, smaller than you might expect, because in real life, the Moon is just over 1/4 the size of Earth. Most people would instinctively place the marble just a few inches away from the apple. But in our scale model, you'd need to hold your arm fully outstretched, and then take several steps back, then several more. The correct distance at this scale is roughly 7 or 8 feet. Far enough that you'd have to walk a couple of strides to pick up the marble after setting the apple down. That amount of space between such small objects feels strange. An apple and a marble separated across a room look like they have nothing to do with each other. Yet in reality, Earth and the Moon are locked in a permanent gravitational dance, orbiting together through space as if connected by an invisible thread. The distance is so large that you could line up every planet in the solar system, Mercury through Neptune, between Earth and the Moon, with room to spare. This simple fact quietly reshapes our sense of scale, revealing just how much empty space exists even within places we think of as close. Now imagine shrinking Earth down even further until it becomes a tiny pea sitting in the palm of your hand. In this version, the Moon becomes a grain of sand, delicate, almost weightless. The distance between them remains enormous. You could walk several paces away and place the grain of sand on a small patch of ground, and the pea in your hand would still feel disproportionately tiny compared to the emptiness in between. Yet in space, this distance is routine. The Moon completes this vast orbit every 27 days, gliding through a path that looks simple from afar, but is astonishingly large when broken down into human scale. The space between Earth and the Moon is also full of subtle movement. Tides rise and fall. Earth's rotation slows gradually. The Moon moves a little farther away every year, about the width of a fingernail. And despite the huge distance, astronauts have traveled this path, not across months or years, but in a matter of days. Their journey through this empty stretch of space remains one of the most profound human experiences, leaving the cradle of Earth and crossing an expanse that looks small in textbooks, but is breathtaking in reality. It's in this comparison, the apple and the marble across a room, the pea and the grain of sand separated by several strides, that we begin to feel the scale of our cosmic neighborhood. Earth and the Moon form a pair, but they are not close neighbors. They are companions kept at a respectful distance, orbiting in a quiet, spacious rhythm. And this rhythm sets the tone for much of the solar system. Small worlds, enormous gaps, and a universe where emptiness stretches farther than our senses naturally understand. Our minds naturally picture the solar system as a compact family of planets huddled around the Sun, each orbit neatly tucked beside the next. But the reality is far different. The planets are extraordinarily small compared to the distances between them. To feel this more clearly, we can gently shrink the entire solar system down to a scale you could explore on foot. A calm nighttime walk through a cosmic model stretched across a familiar landscape. Begin by imagining the Sun as a large beach ball placed gently on the ground. Bright, warm, round, and about the size of something you could lift with both hands. Now imagine Earth in this model. It isn't another beach ball or even a volleyball. It's a tiny pea, a single smooth green sphere small enough to roll between your fingertips. Mercury becomes a grain of sand. Venus becomes a slightly larger bead. Mars shrinks into another pea, barely distinguishable from Earth at a glance. Already, the solar system feels different. The Sun is enormous, and the planets are almost unbelievably small. But what truly stretches your imagination is the space between them. In this gentle, scaled-down walkable model, you place Earth, the tiny pea, not beside the beach ball Sun, but far down a long walkway. Not a step or two, but dozens of steps away. If the beach ball remains at one end of a football field, Earth sits roughly at the 25-yard line, a small pea resting quietly in the grass, barely noticeable from where you began. And that's where you realize something surprising. Even on this shrunken scale, the Earth feels too far away to be part of the same system. Venus sits just slightly closer, another bead along the field. Mars sits slightly farther, another pea at around the 40-yard mark. But then comes the true shock of scale. Jupiter, the giant of our solar system. In this walkable model, Jupiter is still just a small marble. Not a bowling ball, not a basketball, just a marble. Yet you must continue walking almost halfway down the field before placing it in the grass. And even then, it looks tiny compared to the space around it. If you keep going, Saturn becomes another marble, this time with imaginary rings so thin you'd barely notice them. Uranus and Neptune become little beads placed near the far goalposts, separated by stretches of grass so long that people passing by might not even realize these tiny objects are part of the same display. Each planet becomes a tiny point of color, floating within an enormous sea of empty space. Now imagine this scene stretched along an actual path, perhaps a park trail or a quiet street at dusk. At one end sits the beach ball sun. Then, every few minutes of walking, you come across a tiny bead or pea placed carefully on the ground. Between them stretches emptiness, silence, calmness, a peaceful reminder that even though the planets orbit the same star, the solar system is mostly vast, wide-open space. And here is the most astonishing part. Even after placing Neptune near the far edge of the field, you're still not close to the true boundary of the solar system. The Oort cloud, the distant shell of icy debris that marks the outermost edge of the sun's influence, would sit miles and miles away from the beach ball sun. At this scale, you could walk for hours or even days before reaching those far-flung icy grains. In shrinking the solar system into something walkable, we don't just appreciate the smallness of the planets. We feel the enormity of the emptiness between them. We feel how the solar system is less a crowded neighborhood and more a series of tiny worlds drifting through an immense, peaceful desert of space. When you look up at the sun from Earth, it feels like a familiar presence, steady, warm, and constant. But from a cosmic perspective, the sun becomes something far more impressive. It is not just a light in the sky, but a vast sphere of boiling plasma so enormous that numbers alone can't quite convey its scale. To feel its true size, we have to place it gently into images our minds can hold, shrinking and reimagining it until its enormity becomes something we can picture rather than something we try to calculate. Begin by returning to the beach ball version of the sun, large enough to hold, bright in your imagination, yet still small enough to sit comfortably at your feet. When the sun becomes a beach ball, Earth becomes a pea. That comparison alone feels surprising, but it doesn't end there. To fill the actual sun with Earth-sized peas, you would need more than 1 million of them. Imagine pouring bucket after bucket of tiny green peas into a space large enough to hold every one of them, and still having room left over. The scale doesn't just feel large, it feels unimaginable. Now imagine the surface of that beach ball sun. In reality, the sun's surface isn't smooth or calm. It's a roiling sea of plasma, with waves and arcs and swirls that dwarf even the largest storms on Earth. A single solar prominence, one of those giant arcs of erupting material, can stretch hundreds of thousands of miles into space. If we keep the sun as a beach ball in our scaled-down model, one of these prominences would reach several meters away, curling and looping in patterns almost too large to place inside a room. But even as a beach ball, the sun doesn't fully convey its magnitude. So let's try another comparison. Imagine you shrink Earth down to a single grain of sand, a tiny speck resting on your fingertip. The sun, in this new scale, becomes a sphere the size of a large balloon, or perhaps a lantern you could carry with both hands. That grain of sand, Earth, would orbit that lantern, not across a room, but far down a hallway, maybe out the door and across the street. A single speck circling a glowing sphere from a distance that feels too large for them to be related. The sun's size becomes even more astonishing when compared to other stars. Our sun is classified as a yellow dwarf, a mid-sized star. It is neither unusually small nor unusually large, but when we compare it to true cosmic giants, its scale becomes humbling. In our beach ball model, some of the largest stars would be as big as a house or even a building. Others would dwarf entire city blocks. Stars like Betelgeuse or VY Canis Majoris are so massive that if the sun were the size of a beach ball, these supergiants would be vast inflatable domes stretching far beyond your field of view. To make this gentler to imagine, picture the beach ball sun placed on the ground. Now imagine a star so large that if you stood beside it, you wouldn't be able to see the top or even the sides. It would stretch so far around you that it would feel more like standing next to a wall of sky rather than a single object. And yet, these enormous stars exist, quietly glowing in distant parts of the galaxy. So far away their light has traveled hundreds or thousands of years to reach us. And here is the most calming part of this visualization. Despite its enormous size, despite the fact that it dwarfs Earth and fills the sky with warmth, the sun is just one star among hundreds of billions in our galaxy alone. It is a tiny point of light in a sea of even larger wonders. Understanding its scale doesn't make Earth feel small. It makes the universe feel vast, open, and full of quiet marvels waiting to be imagined. The sun's role in our cosmic walk isn't just to impress us with its size, but to prepare our minds for the leaps ahead. Because each step outward in scale makes the previous one feel surprisingly small. As we drift farther outward from the sun, the solar system begins to change in a way that feels almost dreamlike. The planets, even the giant ones, start to seem like tiny markers scattered across a vast field. Their orbits widen into great sweeping arcs. Their presence becomes softer, quieter, almost swallowed by the darkness around them. And the farther we move from the sun, the more the idea of distance starts to dissolve. The solar system stops feeling like a collection of worlds and starts feeling like a cathedral of open space, too large to hold in a single thought. To understand this gently, return to our walkable model. The beach ball sun sits at one end of the field. Earth is a pea far down the grass. Jupiter is a marble placed even farther along. Saturn, Uranus, and Neptune trail behind in quiet intervals, each more distant than the last. But once we reach Neptune, the last major planet, something remarkable happens. The solar system doesn't end. In fact, we've barely stepped into its true size. If Neptune is a small bead at the far end of our imaginary football field, the region beyond it, the Kuiper Belt, stretches even farther. It is filled with countless icy fragments, dwarf planets, and frozen remnants from the solar system's earliest days. In our scaled-down version, this belt extends across several more fields, a wide scattering of specks that you might miss entirely unless you walked slowly and looked closely. Pluto, often imagined as a lonely outpost at the edge of everything, becomes just one tiny bead lost in a vast icy crowd. But even the Kuiper Belt doesn't mark the true boundary. The real edge of the solar system, the place where the sun's gravitational influence finally fades into the galactic background, lies in a region called the Oort cloud. And the Oort cloud is so enormous that it stretches the limits of imagination. If the solar system were still the size of our football field walk, the edge of the Oort cloud would not be another field away, or even several. It would be miles away. You could walk for hours through neighborhoods, down streets, across parks, and still not reach the boundary where the sun's influence ends. To picture this gently, imagine placing your beach ball sun on the ground. Earth is a pea many steps away. Neptune is a bead barely visible in the distance. Now imagine that beyond Neptune, the solar system continues, not for a few more paces, but for the length of an entire city. Every streetlight, every corner store, every quiet late-night road you can picture would be inside that invisible bubble of influence. The Oort cloud forms a great sphere around the sun, so vast that even shrinking it into a city-sized model doesn't fully convey its scale. Inside that enormous volume, objects drift slowly. Tiny icy worlds, quiet and ancient, orbiting the sun so distantly that one full circle can take millions and millions of years. These objects are like cosmic snowflakes, scattered throughout a region so wide that calling it a cloud barely captures how empty it truly is. If the sun were a glowing lantern in the center of a dark stadium, the Oort cloud would stretch far beyond the seats, past the parking lots, and into the surrounding city. And here is the gentle truth that begins to settle in as we imagine these distances. The solar system is far bigger than our intuition allows. The planets are only tiny ornaments hanging near the center. The real solar system is mostly emptiness, stretching outward in a quiet, expansive sphere that dwarfs anything we can picture on Earth. Even when we shrink it down to something walkable, it becomes too large to walk. Even when we shrink it to the scale of a football field, it spills outward into the rest of the town. That is the nature of cosmic size. Every time we think we've reached the limit, the universe reveals that there is still farther to go. And as we drift from the solar system toward the nearest stars, our sense of distance will stretch again, this time into spaces so large that even our walkable model will no longer be enough. When we leave the solar system behind, truly leave it, past the planets, past the Kuiper Belt, past the immense sphere of the Oort cloud, we enter one of the most profound spaces in the universe, the vast, silent region between stars. This region is so enormous, so empty, and so quietly stretched across unimaginable distances that it reshapes everything we think we know about far. Even the word distance begins to lose meaning here. Instead, space feels more like an ocean of darkness, where the nearest points of light are so distant that they may as well be islands on the opposite side of the world. To understand this gently, imagine our walkable scale model again. The sun, our beach ball, sits in your hometown. Earth is a pea somewhere far down the field. Neptune is a tiny bead miles away. The Oort cloud, that outermost shell, is the boundary of your entire city. Now imagine that within this model, the nearest star, Proxima Centauri, isn't across another field or on the next street over. It isn't even in the next town. If the sun were a beach ball in your city, the nearest star would be another beach ball placed on the other side of the continent. A beach ball in Los Angeles if yours were in New York. A beach ball in Vancouver if yours were in Toronto. That staggering distance, stretched across an entire nation, is the space between stars. Even more surprising is the size of the stars themselves in this model. They remain beach balls, Not skyscrapers, not mountains, just beach balls. And yet the gap between them is so vast that each star, including our sun, feels like a lonely beacon in an endless night. If you tried to walk that distance on our model scale, you would need months. Even imagining a car ride or a train journey doesn't fully capture it. The nearby star is so far away that on this walkable map of the universe, you might travel for weeks before even coming close. In reality, the distance between the Sun and Proxima Centauri is just over 4 light-years. The phrase 4 light-years sounds simple, but what it describes is staggering. A light-year is the distance light travels in 1 year, and light moves at 186,000 miles per second. In a single second, light could circle Earth more than 7 times. Yet even that speed, so fast it becomes almost incomprehensible, takes more than 4 years to travel from the Sun to the nearest star. Imagine a beam of light leaving the Sun the moment you take your first breath, drifting through empty space at unimaginable speed, and it would still be traveling long after the candles on your 4th birthday cake were blown out. This emptiness isn't cold or frightening. It's serene, quiet, peaceful. A cosmic desert where nothing rushes, nothing crowds, nothing interrupts the stillness. Every star has its own bubble of planets, icy debris, and gravitational influence. But beyond those bubbles lies vast calm. Stretches of space so empty you could fit thousands of solar systems, lined up one after another without any touching. When astronomers say most of the universe is empty, this is the emptiness they mean. The tranquil void between stars, large enough to swallow human intuition whole. Even the scattered particles drifting through this space are astonishingly sparse. In the quiet region between stars, a single cubic meter, a space roughly the size of a dishwasher, might contain just a handful of atoms. On Earth, that same space contains trillions upon trillions of molecules. Here, though, the emptiness is almost perfect. So perfect that the rare bits of dust and gas drifting through this darkness can travel undisturbed for centuries, even millennia. And yet, despite the distance, this space is not completely silent. The gravitational pull of each star gently tugs on its neighbors. The faint glow of distant galaxies filters through the darkness. Cosmic rays and ancient photons pass by, carrying with them stories of long extinct stars and events that happened millions of years ago. It is a quiet emptiness, but not a dead one. It's an ocean of subtle motion, slow, deliberate, patient. And this ocean is only the beginning. Because as vast as the distance between stars may be, it is nothing compared to the space that stretches between galaxies. Space is so large that even the desert between stars feels small by comparison. As we drift outward from the quiet desert between the stars, we begin to see the structure that holds all those solitary suns together, the Milky Way. From inside it, our galaxy feels like an endless darkness sprinkled with stars. But from the outside, if you could float beyond its edges and look back, you'd see something breathtaking. A vast, gentle spiral of light, turning slowly through space. And the size of this spiral is so immense that even the enormous distances between stars suddenly begin to feel small. To understand this softly, imagine all the stars we've talked about so far. The Sun, Proxima Centauri, the giants like Betelgeuse, and the countless others you see in the night sky. arranged into a single disk. That disk, the Milky Way, contains somewhere between 100 billion and 400 billion stars. The range alone hints at the immensity. The universe is so vast that even counting stars in our own galaxy is difficult. But numbers alone don't help us feel the size. So let's imagine it another way. Picture our walkable model again, where the sun was a beach ball in your city, and the nearest star was a beach ball on the other side of the continent. Now imagine placing not 2 beach balls, but billions of them. Billions of glowing spheres spread out across that same scale. Arranged in a giant spiral shape thousands of miles wide, every single beach ball is a star. Some have planets, some have nothing at all. Some live in clusters, while others drift alone. That's the Milky Way. Not just a collection of stars, but a true cosmic city. If we shrink the entire Milky Way down until it fits in your hands, you would be holding a disk roughly the size of a dinner plate. Thin, delicate, and speckled with glittering grains. The sun, in this tiny model, would be a microscopic particle near the outer third of the plate, too small for your eyes to see. Every dot on that plate represents a star. Every star could represent a solar system. And if you wanted to walk from one side of this plate to the other in the full-scale universe, it would take light itself more than 100,000 years. 100,000 years of constant, uninterrupted travel at the fastest speed allowed by physics, just to cross the width of your imaginary dinner plate. And yet, our place in the Milky Way is humbling. We're not at the center. We're not at the edges. We sit in a quiet neighborhood called the Orion Arm, a small spur between 2 larger spiral arms. Think of it like living on a peaceful street in a vast, bustling city. Our night sky is shaped entirely by our vantage point inside this spiral. When you look up and see the Milky Way as a cloudy band stretching across the darkness, you're seeing the dense glow of billions of distant stars packed together. Not a single cloud, but a river of light. Even the thickness of the Milky Way is immense. If the galaxy were the size of a dinner plate, its thickness would be about the height of 2 stacked coins. And yet, in real terms, that thin layer spans several thousand light years. Inside that thin disk are stars, nebulae, star clusters, and swirling interstellar clouds. An entire ecosystem of cosmic structures stretching so far that our fastest spacecraft would take countless generations to cross even a fraction of it. Another way to visualize the galaxy is to imagine shrinking the Earth to a tiny grain of sand. In this scale, the sun becomes a bright dot, perhaps the size of a pinhead, and the entire Milky Way becomes a vast, glowing arena stretching far beyond anything you could hold or even see in one glance. It becomes a structure so large that, even with these metaphors, your mind might resist picturing it in full. And that resistance is normal. The galaxy is too large for intuition, too vast for everyday experience. It's not something meant to be pictured perfectly. It's something meant to be felt gently, like a soft breath of cosmic scale. But even here, at the level of hundreds of billions of stars arranged into a glowing spiral, we are still nowhere near the largest structures in the universe. Because beyond our galaxy lies a realm that makes the Milky Way look small. A realm where galaxies themselves become the grains of sand, drifting through a far greater cosmic ocean. Once we understand the sheer size of the Milky Way, the next gentle step is placing our tiny solar system into that vast structure. It's one thing to imagine billions of stars spread across a spiral galaxy. It's another to understand how small our place in that galaxy really is, and how much empty space surrounds us in every direction. To feel this scale softly, we'll continue leaning into images the mind can hold. Grains, marbles, lanterns, plates, and drifting specks of light. Begin by picturing the entire solar system again, not just the planets, but the full radius of the Oort cloud, that enormous sphere of icy debris surrounding the sun. In real terms, it stretches almost 3 light-years across. Even at this immense size, the solar system is hardly a blip inside the Milky Way. So let's shrink it gently into something familiar. Imagine the entire solar system, sun, planets, Kuiper belt, Oort cloud, everything, reduced to the size of a small coin. Not a large coin or a heavy one, something small enough to balance on your fingertip. That coin represents every world we know, every moon, every comet, every place humans have ever imagined exploring. Now imagine holding that coin up in front of you. It feels tangible, simple, contained. Now imagine the Milky Way on this same scale. That tiny coin, balancing on your finger, would sit inside a galaxy the size of North America. Not a city, not a state, not even a province, a whole continent, stretching from coastline to coastline, filled with billions of little lights representing stars. The sun, in this vast continental model, sits far from the center, in a suburb on the outer edge of this grand cosmic landscape. And your tiny coin is just one small intersection in that enormous glowing map. Another way to feel this is with the dinner plate model from earlier. If the Milky Way were a dinner plate in your hands, the entire solar system would be smaller than a single grain of dust floating near one of the edges. In fact, the sun and all its planets would be too small to see without magnification. You could blow gently across the plate, and the solar system would drift away unnoticed. That's how minuscule our place in the galaxy truly is. To soften this even further, imagine the night sky as a view from inside this enormous plate. Every star you've ever seen with the naked eye is just one of the nearest grains of light surrounding us. The vast majority of stars in the Milky Way, hundreds of billions of them, are too far away to see without powerful telescopes. Even the glittering band of the Milky Way that stretches across dark skies is only a narrow glimpse into one part of this immense structure. It's like standing on a quiet street at night and seeing only the porch lights of the houses nearest to you, while the rest of the city stretches far beyond the horizon. But here's something even more delicately humbling. In our plate-sized galaxy, stars themselves are astonishingly far apart. If you placed grains of sand on the dinner plate to represent stars, you wouldn't sprinkle them close together. You would place each grain with enormous gaps between them, so large in fact that the grains would barely look like part of the same object. The Milky Way isn't crowded, it's spacious. Each star, including the sun, lives in its own enormous bubble of emptiness, drifting quietly in a sea of space so wide it makes even the solar system feel intimate. And yet, the galaxy holds its structure together. Gravity keeps the stars orbiting in a grand spiral, like dancers moving in slow, elegant arcs. The Milky Way rotates so gradually that a single orbit takes the sun over 200 million years. When dinosaurs roamed Earth, the sun was in a completely different part of the galaxy. The galaxy itself is a massive, quiet carousel, turning slowly through the dark, its stars glowing like lanterns across a disk so large that even light, the fastest thing in existence, would take 100,000 years to cross it. All of this scale, the coin-sized solar system inside a continent, the grain of dust on the rim of a plate, the gaps between stars, helps us feel not small, but calm. Because while our position in the galaxy is tiny, it's also safe, serene, and surrounded by a universe whose scale is so vast that everyday worries seem to soften in comparison. And yet, as enormous as the Milky Way is, it is only one among billions of galaxies, each one a glowing plate, a swirling city, a vast arena of stars drifting through an even larger cosmic ocean. As we float gently through the Milky Way in our imagination, we begin to notice that not all stars are scattered evenly. Some gather into clusters, like quiet islands in a vast ocean. Others illuminate enormous clouds of gas and dust, nebulae, glowing in shapes that resemble soft brushstrokes across the darkness. These structures help us understand the scale of the galaxy in a different way, because they show us how stars are born, where they gather, and how even enormous cosmic features can feel small against the backdrop of the Milky Way. To imagine a star cluster softly, picture a handful of glitter sprinkled across a dark piece of velvet. Each glittering point represents a star, and each one is a sun in its own right. Some clusters are small, containing a few dozen stars. Others hold hundreds or even thousands. Yet even the largest clusters are tiny compared to the galaxy itself. In our dinner plate model of the Milky Way, a massive star cluster would be no bigger than a grain of sand, a bright speck somewhere on the plate's surface. Each speck is a family of stars, bound together by gravity, drifting through the galaxy like a small caravan. One of the most famous clusters visible from Earth is the Pleiades, also called the Seven Sisters. When you look at them in the night sky, they appear close together, like small seeds scattered across a dark tabletop. But in reality, the distances between those stars are enormous. If you shrank the cluster so that each star was the size of a pea, they would be separated by gaps the length of entire city blocks. What appears to be a close-knit group is actually a vast arrangement of suns drifting gently together across light years of space. Nebulae, on the other hand, are some of the most visually striking structures in the galaxy. They are enormous clouds of gas and dust, places where stars are born or where they fade at the end of their lives. The Orion Nebula, one of the closest star-forming regions to Earth, is vast enough that if you could see it with perfect clarity, it would stretch across a portion of the sky larger than the full moon. But even that doesn't convey its size. If our entire solar system were shrunk down to the size of a grain of salt, the Orion Nebula would be the size of a large room, wide, airy, softly glowing. In our continent-sized model of the galaxy, nebulae become enormous regions spanning the length of entire cities. Imagine a glowing, misty cloud drifting above an entire metropolitan area, its edges stretching beyond what the eye could take in at once. That is what nebulae look like on a cosmic scale. Gentle giants, softly illuminated by the stars forming within them. Some nebulae are even larger, spanning hundreds of light years. These colossal structures are so vast that if a spacecraft traveled at the speed of light, it would spend centuries crossing from one side to the other. Yet even these immense clouds are small compared to the galaxy in which they reside. It's similar to imagining a single cloud floating above an entire continent, large and dramatic, but still only a tiny fraction of the whole. Nebulae also help us understand the life cycle of stars. A star forms within a nebula when gravity pulls gas and dust together into a dense region. Over millions of years, this region collapses into a sphere and heats up until nuclear fusion begins. At that moment, a new star is born, shining gently into the surrounding cloud. Over time, the light and wind from the star carve shapes into the nebula, creating curves, tendrils, and arcs that look like cosmic sculptures. These shapes can be so large that even imagining them on human scales requires stretching the mind gently across vast distances. Even the remnants of dying stars, supernova remnants, form nebula-like structures. These remnants can span tens of light years, glowing softly as the material spreads out into space. If you're imagining the dinner plate Milky Way again, a supernova remnant would be no bigger than a speck of dust on its surface. Inside that tiny speck, though, entire stars have lived and died. Star clusters and nebulae remind us of something gentle and profound. Even the large, dramatic features of the galaxy are just tiny details in an unimaginably vast system. They are the individual brushstrokes on a canvas bigger than our comprehension. And yet, each cluster and nebula plays a part in the grand story of the Milky Way. One tiny island of light drifting within a cosmic ocean that stretches beyond anything we've imagined so far. Soon, we'll step even farther out, where galaxies themselves become the grains of sand, drifting through an even larger universe. As we continue drifting outward, gently leaving behind individual stars, clusters, and nebulae, a new concept becomes essential to understanding the size of the universe: light. And more specifically, the time it takes for light to travel across cosmic distances. Light travels faster than anything we know, yet even its incredible speed to become sluggish when stretched across the scales of galaxies and beyond. And in that slowness, something profound emerges, the boundaries of what we can see. Imagine holding a lantern in a dark room. When you turn it on, the light fills the space instantly. Your mind interprets it as immediate, as if light simply appears wherever it's needed. But in reality, even in a small room, light is still traveling. It moves so quickly that you can't notice the delay. But in space, where the distances stretch far beyond anything familiar, that delay becomes meaningful. Light doesn't just illuminate, it carries information. It tells us how far away something is, by how long it took to arrive. To feel this gently, imagine shrinking light itself into something you can picture. Perhaps a small glowing bead drifting across a dark pond. The bead moves quickly, leaving a faint shimmering line behind it. But the pond is vast, and even though the bead moves fast, you can still watch it travel from one side to the other. That's what happens on cosmic scales. Light rushes outward, but its journey takes time. Seconds, years, centuries, millennia. Consider the light from the sun. It takes just over 8 minutes to reach Earth. That means every sunrise, every ray of warmth on your skin, every shimmering reflection on the ocean's surface is 8 minutes old. you never see the sun as it is in this moment. You see it as it was 8 minutes ago. That delay feels small, but move farther out, and the delays become astounding. From the nearest star, Proxima Centauri, light takes over 4 years to reach us. If that star flickered or vanished, we wouldn't know for years. From the center of the Milky Way, our galaxy's glowing, mysterious heart, light takes over 25,000 years to reach Earth. The glow we see from that region is older than human civilization itself. It comes from a time when early humans were still painting the first images onto cave walls. And from the farthest reaches of the observable universe, some of the light we receive has been traveling for more than 13 billion years. When that light began its journey, Earth didn't exist yet. The sun didn't exist. Our galaxy hadn't formed. That light started traveling across the universe long before our planet was even a possibility. So when astronomers look at distant galaxies on the edge of the observable universe, they are literally seeing into the past, into a time when the universe itself was young, crowded with hot clouds of newly formed matter. This interaction between distance and time creates a boundary around what we can observe. Not because the universe ends there, but because light hasn't had enough time to reach us from beyond that point. Imagine standing in a vast, dark valley holding a lantern. The lantern illuminates only the nearest slopes. The rest of the valley stretches on, unseen. You know there is more beyond the light's reach, but you cannot see it. That's what the observable universe is, a sphere of visibility around us, limited not by walls or edges, but by time itself. Even within the Milky Way, the journey of light reveals the galaxy's staggering scale. Light traveling from one end of the galaxy to the other would need over 100,000 years. Imagine a beam of light beginning its journey before humans even existed, drifting through space at unimaginable speed, passing star after star, crossing vast empty regions, and still not reaching the far side until long after countless generations have come and gone. That's how large a galaxy truly is. And yet, even these immense scales, billions of years of travel time, tens of thousands of light years across, are still small compared to what lies beyond. Because once we step outside the Milky Way, galaxies themselves become tiny points of light drifting in an even larger cosmic web. Light from those galaxies stretches, reddens, slows in a sense, revealing that the universe isn't just large, it's expanding, stretching the distances themselves like a slowly inflating ocean. Our intuitions about size begin to loosen in this section, replaced by an understanding that distance and time are inseparable in the cosmos. To know how far something is, we must also know how long its light has traveled. And as the universe grows, these distances only become greater. The more we explore outward, the deeper into time we peer, until distance itself becomes a doorway to the past. Soon, we will step beyond the Milky Way into the realm where galaxies float through space, the way stars float within a galaxy. A scale so enormous that even our expanded imagination will have to stretch gently once again. Once we fully absorb the size of the Milky Way, a gentle but staggering realization begins to form. Our galaxy is not alone. It is just one glowing island in a vast cosmic ocean filled with countless others. And as we drift outward in our imagination, leaving behind the spiral arms and star clouds, of the Milky Way, we step into a realm where entire galaxies become the building blocks of scale, where each one is a shimmering city of stars, drifting through space like lanterns on an endless sea. To begin feeling this softly, imagine the Milky Way again as a dinner plate glowing faintly in a dark room. You hold this plate carefully in your hands, feeling its size, its weight, its presence. Now imagine placing it gently on the floor. In the distance, far across the room, another plate begins to glow. The Andromeda Galaxy, our closest large neighbor. It sits roughly 2 million light-years away, glowing faintly like a lantern on the other side of a quiet field at night. If the Milky Way were a dinner plate on your living room floor, Andromeda would be another plate placed 2 long city blocks away. You could walk for minutes, even hours, and that second plate would still appear small, delicate, softly lit. And yet, even at that distance, it is our nearest large galactic neighbor. The space between galaxies is so vast that it makes the gulf between stars look almost intimate. In reality, Andromeda is enormous, even slightly larger than the Milky Way. If the Milky Way contains hundreds of billions of stars, Andromeda contains hundreds of billions more. Yet in our imagination, both galaxies become 2 glowing plates floating in the darkness, separated by a stretch of space so large that light itself takes more than 2 million years to travel between them. To feel this distance more deeply, imagine shrinking the Milky Way into a single glowing grain of sand. Now imagine placing that grain on a beach, a real beach, with thousands of other grains scattered all around. The grain you place is our galaxy. The nearest similar grain, representing Andromeda, sits several steps away. All the grains between them represent smaller galaxies, dwarf galaxies, or faint smudges of light too dim to notice without magnification. The beach stretches in every direction, filled with grains representing galaxies big and small. Astronomers call this region the local group, a small family of roughly 80 galaxies bound together by gravity. Some are large spirals, many are tiny dwarfs with only a few million stars. If you were holding the dinner plate Milky Way again, and Andromeda or another plate down the street, these dwarf galaxies would be like tiny beads or glitter scattered between them, subtle points of light that drift in the same gentle gravitational current. But the local group is still small. To understand its true place in the universe, imagine stepping farther back, way back, until the galaxy-filled beach becomes a single grain of sand in your hand. That grain, representing the local group, is part of an even larger structure, the Virgo supercluster, a sprawling region containing thousands of galaxies. If our local group is a grain of sand, the Virgo supercluster becomes a pile of sand stretching across a long, quiet shoreline, each grain representing a galaxy cluster. And even that isn't the end of it. Far beyond Virgo lies an even larger structure, a breathtakingly vast region called Laniakea, the home of our local group and thousands of others. If the Virgo supercluster is a beach, Laniakea is an entire coastline, long, curving, intricate, stretching farther than your imagination wants to travel. Each supercluster is like a province, a region in a cosmic continent made not of land, but of galaxies woven together by gravity. And beyond Laniakea, still more, a gentle web of structure woven across the universe, galaxy clusters linked by filaments of dark matter, glowing strings of light stretching across billions of light years. In this scale, galaxies are no longer dinner plates or grains of sand. They are mere flecks of dust drifting in a vast, interconnected cosmic tapestry. The idea that galaxies themselves become small in this larger view is both soothing and awe-inspiring. Everything we've ever known is inside one galaxy, and yet the universe holds billions, possibly trillions, of them. Each one is a quiet island of stars, drifting in an ocean too large to cross, too vast to fully imagine, too serene to fully describe. And as we drift forward, we'll explore the space between these galaxies, a space so empty, so wide, and so quiet that even the desert between stars feels like a familiar neighborhood in comparison. As we continue drifting outward, leaving behind the Milky Way and even the nearby galaxies of the local group, we enter one of the most profound regions in the entire universe, intergalactic space. If the emptiness between stars felt enormous, the emptiness between galaxies is something else entirely. It is one of the quietest, widest, most spacious realms imaginable, a place where distance becomes so vast that familiar metaphors begin to dissolve, and the scale of everything takes on an almost dreamlike quality. To ease into this, imagine again our walkable cosmic model. The Milky Way was a glowing dinner plate on the floor, and Andromeda was another plate placed 2 city blocks away. Now imagine that you pick up both plates and place them on a long, dark beach at night. The plates glow gently in the sand, like small lanterns. Now look around. The beach stretches in every direction, quiet and empty. Far down the shoreline, barely visible, faint points of light mark the positions of other galaxies, each one a plate of stars, softly glowing in the distance. If the Milky Way were a single grain of sand on this beach, the nearest similar grain, representing a neighboring large galaxy, would still sit several steps away, and the next one would be several more steps, and then several more. Entire gaps between grains would stretch longer than the distances you walked within the galaxy itself. That is intergalactic space, a realm made not of stars or clusters, but of vast stretches of gentle, quiet nothingness. On real cosmic scales, the distances here are staggering. The space between galaxies in a cluster can be hundreds of thousands of light years across, and the space between clusters can be millions of light years. Imagine a beam of light, that glowing bead drifting across the dark pond from earlier, and picture it traveling not for years or centuries, but for millions of years, just to move from one galaxy to the next. That is how wide these intergalactic regions truly are. And yet, despite this emptiness, the universe is not silent. Gravity quietly threads these galaxies together. Invisible strands of dark matter form a web-like structure that stretches across billions of light years. Imagine a subtle, delicate lace spread across an enormous table. Thin filaments, each connecting distant points. Where these filaments intersect, galaxies gather into clusters. Where clusters intersect, superclusters form. And where superclusters connect, the universe reveals its most astonishing pattern. A cosmic web, each glowing point a galaxy, each thread a bridge of matter linking one region to the next. Trying to visualize this gently is a challenge, but we can soften it. Imagine standing on a quiet hillside at night, watching fireflies glow across a valley. Most of the valley is dark, but the fireflies flicker in clusters, connected by faint trails of light. The darkness between them feels huge, yet they are all part of the same summer landscape. Intergalactic space is like that. Darkness filled with distant glimmers, all woven together in ways we cannot see directly. If we shrink the entire universe down until galaxies become tiny specks, the space between them becomes so large that the specks almost seem unrelated. But everything is held together by gravity, stretching across unimaginable distances. Even here, in the vastest emptiness, the universe behaves like a single, interconnected structure. To understand this next part softly, imagine taking a step back, not physically, but conceptually, until galaxies become tiny symbols scattered on a map. Now those symbols begin to arrange themselves. Some gather into clusters, some into long strings, some into sweeping arcs like brushstrokes on a cosmic canvas. Between them lie gigantic voids, regions of space so empty that if the Milky Way were a single grain of sand, the nearest galaxy in that void would sit miles away on our scale. These voids are not rare. They fill much of the universe, and they help us understand something remarkable. Even though galaxies feel enormous, and even though clusters of galaxies feel unimaginably huge, the universe is mostly made of nothing. Calm, stretching, quiet nothing. It is a vastness that softens the mind, a reminder that scale is less about numbers and more about the gentle feeling of drifting through something infinite. As we drift farther outward, we'll soon reach the realm where we stop seeing individual galaxies altogether and instead begin to see the entire structure of the universe itself. The cosmic web awaits, an enormous network of light and shadow stretching for billions of light years in every direction. As we move even farther outward, beyond individual galaxies and beyond the wide, empty spaces separating them, a new pattern begins to emerge. A pattern so large and delicate that, in many ways, it resembles the structure of a living organism. This is the cosmic web, the largest known arrangement of matter in the universe. It is a softly interconnected network of galaxies, clusters, and dark matter filaments that spans billions of light years. And in this vastness, our imagination must stretch in ways it never has before. To ease into this, imagine looking at a map of a coastline from high above. Rivers branch outward like veins. Bays curve inward. Channels weave through the landscape. Now imagine something even more intricate, the branching of a tree, or the pattern of lightning illuminating the sky. The cosmic web looks remarkably similar, but on a scale so large that even metaphors begin to feel small. Yet despite the enormity, the structure itself is gentle, elegant, almost delicate in its form. Start by picturing galaxies not as individual islands, but as lights on the nodes of a giant net. Each point on this net is a galaxy or a cluster of galaxies. The strands connecting them, invisible threads made of dark matter and sparse gas, stretch across unimaginable distances. In your mind, imagine standing far above a nighttime landscape dotted with lanterns. Between the lanterns, thin threads of light glow faintly, connecting some in long lines, others in branching patterns that reach across the darkness like glowing roots. That is the essence of the cosmic web. If we shrink the entire observable universe into something the size of a massive sphere you could hold in your arms, the cosmic web becomes a lace-like structure woven through the interior. The galaxies become tiny motes of light scattered along the filaments. The gaps between them, the cosmic voids, form enormous pockets of empty space. These voids are not small. Even in this shrunken model, each void would be larger than continents. And in reality, each void spans hundreds of millions of light years across. To soften this visualization even more, imagine looking at a sponge under a bright light. The structure is porous, full of holes, full of interconnected passages. Now replace the sponge material with galaxies, hundreds of billions of galaxies, arranged along the walls of those passageways. The empty spaces inside the sponge represent cosmic voids, while the surfaces represent filaments and clusters. That's how the universe is structured on the largest scale we can observe. But this structure isn't just beautiful, it's dynamic. Over billions of years, gravity has pulled matter together into these delicate filaments. Dark matter, which we cannot see directly, provides the underlying scaffolding. Visible matter, like gas and stars, slowly collects along these invisible lines. Over countless millennia, galaxies form where the lines intersect, like dewdrops forming where spiderweb threads cross. Clusters build upon clusters, gradually shaping the landscape of the cosmos. And the size of these filaments is almost beyond comprehension. Some stretch over 1 billion light years from end to end. 1 billion light years is such a staggering distance that even imagining light traveling across that span becomes difficult. If you picture a glowing bead drifting across a calm lake, moving at the fastest speed in the universe, it would need more than 1 billion years to cross the longest filaments. This means that even the fastest thing we know is effectively slow on the scale of the cosmic web. And yet, for all its immensity, the cosmic web remains subtle. It is not a solid structure, but a pattern of density, a whisper of where matter has chosen to gather over cosmic time. If you could float through it, the web wouldn't feel like a physical net or a bright lattice. It would feel like drifting through vast regions of calm, coming upon clusters of galaxies like distant cities glowing in the night, each connected by thin, faint highways of starlight and gravitational pull. Perhaps the gentlest way to imagine the cosmic web is to think of it as a map of the universe's history. Every filament traces the movement of matter since the earliest moments of existence. Every cluster marks a place where gravity patiently shaped the cosmos. Every void represents a space where matter never gathered. And altogether, these patterns reveal the universe not as a random scattering of galaxies, but as a grand, intricate design written across the fabric of cosmic time. The cosmic web is the ultimate expression of scale, a structure so large that galaxies themselves become tiny details within it. And as we drift even farther outward in the next part of our journey, we'll begin to explore the outer boundaries of what we can see, and how the size of the observable universe compares to the universe beyond our sight. As we continue expanding our sense of scale, we reach a concept that gently combines everything we've explored so far: the observable universe. This is not the entire universe, not even close, but rather the sphere of space from which light has had enough time to reach us since the beginning of cosmic history. It is a boundary defined not by walls or edges, but by time itself. And once we begin to imagine its size, the enormity of everything we've discussed so far begins to feel small by comparison. To ease into this, let's return to the idea of light as a glowing bead drifting across a vast pond. From the moment the universe began, roughly 13.8 billion years ago, light has been traveling outward in all directions. But here's the surprising part. Although the universe is 13.8 billion years old, the observable universe is much larger than 13.8 billion light years. In fact, it is nearly 93 billion light years across. This happens because space itself is expanding, stretching like a cosmic fabric, while the ancient light continues on its journey. Imagine a calm balloon being slowly inflated. Dust particles drawn on its surface drift apart, even though they remain fixed in place. If one particle sends out a signal, the stretching surface carries the other particles farther away while the signal travels. In this gentle stretching, space itself becomes part of the measurement. The observable universe is the distance that ancient light has traveled, plus the additional stretching of space along the way. To imagine this softly, picture the entire observable universe as a perfectly round sphere. Now shrink it until it becomes the size of a glowing beach ball floating lightly in your room. Every point on its surface represents the farthest place from which light has had time to reach Earth. The interior of this glowing ball contains every galaxy, star, nebula, cluster, and filament of cosmic structure that we can possibly observe. But even this enormous sphere, this beach ball universe, is only the part we can see. Beyond it lies the unobservable universe, stretching farther and farther, possibly into infinity. Now imagine placing a tiny pinhead at the very center of this glowing beach ball. That pinhead represents our solar system. Everything we know, everything we've seen, every photograph from telescopes, every star visible in the night sky. The pinhead is so small, so delicate, that it barely interrupts the space around it, and the glowing sphere around it isn't empty. Inside it lie 2 trillion galaxies, each one home to billions or trillions of stars. To make this even gentler to imagine, think of the observable universe as a vast cosmic garden. Each galaxy is a flower or a tree, glowing faintly in the soft night air. The paths between them are long and tranquil, winding through spaces so quiet that even light takes millions or billions of years to cross from one bloom to the next. In our garden, the Milky Way is just a single blossom among trillions, nestled in a corner of a field so large you cannot see its boundaries. Another way to picture the scale is to shrink the entire observable universe until it becomes the size of Earth. In this model, the Milky Way becomes a tiny grain of dust on the surface, and our solar system, it becomes smaller than a molecule within that grain. You could circle the Earth thousands of times and still never notice the spot where our cosmic home rests. The distances are so large, so delicately layered, that even metaphors begin to feel stretched thin. What's most remarkable is that everything we've discussed, the solar system, the Milky Way, galaxy clusters, superclusters, and the cosmic web, fits inside this observable sphere. All of cosmic history, all the light that has ever reached us, all the galaxies we've ever seen through telescopes, every star ever catalogued, all of it is contained inside this 93 billion light-year bubble. And although this size feels final, it isn't. This sphere is not the edge of the universe. It's simply the edge of what we can see. Beyond that boundary, the universe continues, possibly endlessly, filled with galaxies that will remain forever invisible to us because their light hasn't had enough time to reach Earth. It's not a wall, not an edge, not an ending. It's simply a limit set by the age of the universe and the speed of light. In many ways, the observable universe is less a physical boundary and more a reminder of how young we are in cosmic time. We are watching a film that began long before we arrived, and we can only see the scenes whose light has reached us. Beyond that, the story continues in silence, waiting in the darkness. Soon, we'll step softly beyond even this sphere, exploring how the universe may stretch far past what we can observe, and why the unobservable universe might dwarf even the vast cosmic ocean we've just imagined. Now that we've imagined the observable universe, the glowing sphere of everything whose light has managed to reach us, it's natural to wonder what lies beyond it. And the gentle truth is this: almost everything. The observable universe is not the boundary of existence. It is only the boundary of visibility. Beyond that horizon stretches a universe so vast, so unconstrained, and so deeply removed from our reach that its size may well be infinite. And even if it isn't infinite, the portion we can see is only a tiny fraction of the whole. To ease into this idea softly, return to the glowing beach ball model from earlier. The beach ball represented the observable universe, the limit of what light has delivered to us since the beginning of time. Now imagine placing that beach ball on the floor of a dark, quiet gymnasium. The gym feels large compared to the beach ball, almost eerily so. But now imagine that beyond the gym, there are more rooms, and beyond those rooms, more buildings, and beyond those buildings, more cities, more countryside, more coastlines, more continents. The beach ball doesn't even begin to represent the size of everything that might exist. It's simply the part illuminated by light that has had time to reach us. Another way to imagine the unobservable universe is to shrink the observable universe until it becomes the size of a small marble resting in your hand. That marble contains all the galaxies, stars, clusters, filaments, and voids we've ever detected. Now imagine yourself standing on a vast, quiet beach at dusk. The marble is at your feet, glowing softly. But the rest of the beach, the dunes, the ocean, the horizon, the sky, all lie far beyond the marble's limits. In this metaphor, the beach represents the full universe, and the marble represents the part we can see. In reality, the universe has been expanding since its earliest moments. But because space itself is stretching, regions far beyond the observable boundary are moving away from us faster than the speed of light. Not because they're traveling through space faster than light, which is impossible, but because the space between us and them is expanding. This means their light will never reach us. Not in a million years, not in a billion, not ever. These unreachable regions are not smaller, quieter, or simpler than the observable universe. They are likely just as rich, just as structured, just as full of galaxies and stars. They simply lie beyond our cosmic horizon. To imagine this gently Picture yourself on a calm, foggy shoreline. The air is thick with mist, and you can only see a short distance down the beach, maybe a few dozen steps. You know the beach continues. You can hear distant waves, feel the openness around you, but your eyes can only reach so far. The fog doesn't end the beach. It simply hides the rest from view. Our cosmic horizon works the same way. The universe continues far beyond our line of sight. Light simply hasn't had enough time to reach us from the farthest regions. The rest of existence is wrapped in a kind of cosmic fog, not one made of clouds, but one made of time. Some theories suggest that the universe might be much larger than what we can observe, possibly thousands or millions of times larger. Others propose that the universe might be infinite, extending endlessly in all directions. In an infinite universe, beyond every cluster of galaxies lies another cluster, and beyond that another, and beyond that another still. The cosmic web would stretch on and on, forming patterns so vast that even our most powerful telescopes could never detect them. There's also a possibility, one scientist takes seriously, that the universe may contain regions so far away that they follow entirely different physical rules, different forces, different constants, perhaps even different forms of matter. These areas would be unreachable, not just physically, but conceptually. They would exist in the same universe, but be forever separated from our own cosmic neighborhood. And then there are theories about bubble universes. Perhaps our observable universe is just one bubble in a larger froth of universes, each bubble expanding and drifting like soap bubbles clustered together. If true, the size of the full universe would be far beyond any metaphor we could easily imagine. Not just galaxies and filaments, but multiple universes floating in a larger space where distance and time behave in unfamiliar ways. Yet despite all this, the unobservable universe doesn't need to overwhelm the mind. In a quiet way, it offers comfort. It reminds us that existence is far larger than our problems or worries. It invites us to imagine a cosmos too big to ever fully know, yet gentle enough to contemplate calmly. The universe stretches on in all directions, far beyond our reach, far beyond our sight, far beyond our comprehension. A vast, quiet expanse where the story continues, softly, endlessly. And now, having drifted past the visible boundary of the cosmos, we can explore something even more subtle. How the universe continues to grow, and how expansion itself shapes the meaning of distance on cosmic scales. Now that we've drifted beyond the observable boundary, there's one more concept that gently reshapes how we understand the size of everything. Expansion. Not expanding into something, not growing outward from a center like an explosion, but something quieter and stranger, the stretching of space itself. This idea is essential to truly feeling the scale of the universe, because it shows us that distance is not fixed. The universe is not a static stage with galaxies sitting still. It is a living, changing fabric that is constantly stretching, altering the very meaning of far. To feel this softly, imagine a simple piece of fabric lying across your lap. Smooth, calm, unmarked. Now imagine that the fabric begins to stretch, not because you pulled the edges, but because every thread is slowly lengthening on its own. The fabric expands everywhere, all at once. Points that were once close drift apart, not because they are moving across the fabric, but because the fabric between them is increasing. This is how the universe expands. Galaxies are not flying outward through empty space. Space itself is stretching, gently carrying everything with it. Now picture tiny specks on this fabric, grains of sand resting on its surface. These grains don't move on their own. They simply drift farther apart as the fabric grows beneath them. In the real universe, these grains represent clusters of galaxies, held together locally by gravity. But the fabric between these clusters stretches. Over millions and billions of years, the distances between them become larger, even though neither cluster has taken a single step. If we shrink the universe into something we can hold, a calm, glowing balloon, this expansion becomes easier to imagine. Draw several dots on the balloon with a marker. When the balloon inflates, every dot moves away from every other dot. No dot is the center of the expansion. Every dot sees all the others drifting away. This is exactly what happens in the universe. Everywhere looks like the center, and galaxies see each other receding no matter where they're located. But there's a gentle twist. The farther away something is, the faster it appears to recede. This isn't because distant galaxies are rushing away faster. It's because there is more space between you and them, and all of that space is stretching. Imagine drawing two dots on the balloon very close together. When the balloon inflates, they drift apart slowly, but draw two dots on opposite sides, and they separate more quickly as the balloon expands. The larger the distance, the more stretching occurs. This is why galaxies at the edge of what we can observe seem to recede at incredible speeds, faster than light even. But this doesn't break the laws of physics, because nothing is moving through space faster than light. Instead, space itself is expanding between us and those distant galaxies. It's like two people standing still on a moving walkway that lengthens beneath their feet. They remain still, but the ground stretches, carrying them apart. To picture this gently, imagine standing in a quiet field at dusk. Fireflies glow all around. Some appear close, some far. Now imagine the field itself slowly expanding. The fireflies remain in place, hovering softly, but the space between you and the farthest ones increases with every passing moment. You watch them drift farther away without ever moving. The universe behaves in much the same way, except the field is billions of light years wide, and the drifting occurs across expanses too large for the mind to fully hold. This expansion affects everything we've discussed so far. It stretches the cosmic web. It widens the gaps between galaxy clusters. It increases the size of the observable universe each moment. And it subtly alters the ancient light traveling toward us. As space expands, it stretches that light, lengthening its wavelength and softening its energy. This is why distant galaxies appear redder, not because they emit red light, but because the space between us and them has stretched the light on its journey. In many ways, expansion gives the universe a gentle sense of motion, even in its stillness. Galaxies form, drift, and evolve, but the underlying expansion is quiet, patient, and persistent. It has been happening for nearly the entire history of the cosmos, and it will continue, slowly stretching the fabric of space so that the galaxies we see today will drift farther and farther into the distance. Some models, suggest that this expansion will continue forever, causing galaxies to move beyond reach one by one, until our observable universe becomes quieter and dimmer over trillions of years. Other models suggest expansion may eventually slow. Still others imagine exotic possibilities, but all of them agree on one thing: the universe is vast, and it is growing vaster still. Understanding expansion helps us see cosmic size in its truest form, not as a static measurement, but as something dynamic, fluid, and endlessly unfolding. The universe is not just big, it is getting bigger, quietly and continuously, in a way that reshapes everything we think about scale. And now, as we drift onward, we can explore how the universe's size relates not only to space, but also to time, and why looking deep into space is the same as looking deep into the past. When we talk about the size of the universe, we often imagine distances, vast stretches of space separating stars, galaxies, and clusters. But there is another layer to these distances, one that gently transforms the way we understand everything we see in the night sky. In the universe, distance and time are inseparable. The farther away something is, the older the light we're seeing. Every look outward is also a look backward. The night sky is not just a map of space. It is a timeline of cosmic history. To ease into this gently, imagine a quiet lake at night. You light a small lantern on the shore. Its glow spreads across the water. Up close, the ripples reach you almost instantly. Farther down the shore, the glow takes longer to arrive. Now imagine that the lantern isn't a lantern at all, but a star. And the lake isn't water, but the fabric of space. Light spreads outward in every direction, and the farther away you are, the older that light becomes by the time it reaches you. This is why when we look at the moon, we see it as it was just over a second ago. When we look at the sun, we see it as it was 8 minutes ago. When we look at distant stars in the Milky Way, we may be seeing them as they were hundreds or thousands of years ago. And when we look at distant galaxies, we are seeing them as they were millions or billions of years ago, long before Earth formed, long before any human existed, long before our solar system took shape. Imagine holding a photo album that begins with pictures from your childhood and stretches backward into the past, long before you were born. Not just decades, but centuries, millennia, eons. Each page you flip shows a moment deeper in time. That is what looking through a telescope is like. Every distant galaxy is another page, another chapter from the universe's past. The farther away the galaxy is, the older the chapter we're reading. To make this softer still, imagine shrinking the entire universe into a long, quiet hallway. Along the hallway's walls are glowing frames, each one showing a moment frozen in time. The frames nearest to you show the universe as it is today. The next set shows it as it was millions of years ago. Farther down, the frames show billions of years ago. And if you walk to the very end of the hallway, you reach frames showing the universe as a newborn, glowing, hot, and filled with early light from the first galaxies. This hallway represents the time it takes for light to travel. When we point telescopes into deep space, we are walking down that hallway, looking at older and older frames. Even the most advanced telescopes, like the James Webb Space Telescope, don't just look far, they look back. When Webb captured ancient galaxies at the edge of visibility, it was photographing scenes from about 13 billion years ago. That means the light from those galaxies began its journey when the universe was young, when galaxies were still forming their first stars. We aren't seeing those galaxies as they are now. We're seeing them as they were when the universe was only a few 100 million years old. This means that size in the universe isn't just physical, it's temporal. When we speak of billions of light years, we're describing not just how far away something is, but how old the image is. The observable universe is like a vast spherical archive of time. Near the center is the present moment. Farther out are ancient chapters. And at the very edge is the universe's infancy, a faint glow known as the cosmic microwave background, the oldest light we can detect. Imagine that ancient light as the last pages of a very old book, fragile, soft, and dim. This light has traveled for nearly 14 billion years, stretched and faded by the expansion of space. And yet, it reaches us still, carrying whispers of the universe's earliest moments. It's like hearing a gentle echo from a time so distant that our language has no true way to describe it. And this is where the concept of size becomes even more dreamlike. The universe is so large that even with our most powerful telescopes, we will always be looking backward, never outward into the present. We cannot see the universe as it is now, only as it was. The true current size of the universe is larger than anything we can observe, because the light from its farthest regions has not yet arrived. Understanding this brings a gentle perspective. When we gaze at the night sky, we are not just seeing stars. We are witnessing history. We are seeing ancient light that has traveled across cosmic oceans to reach our eyes. Every flicker is a story from long ago. Every distant glow is a message from a different time. And every part of the universe we see is only a small chapter in a far larger book. One that continues to unfold quietly and endlessly beyond the limits of our sight. Next, we'll explore how galaxies themselves evolve across these vast spans of time, and how what we see today is only a moment in their long, tranquil lifetimes. When we look at galaxies scattered across the universe, glowing softly in every direction, it's easy to imagine them as still images, fixed, frozen, quietly drifting. But galaxies are anything but static. Each one is a living, evolving structure, undergoing slow, graceful changes over spans of time so vast that a single human lifetime doesn't even register. To understand the size of the universe, we also have to understand the size of cosmic time, the gentle, unhurried way galaxies grow, transform, and age. To imagine this softly, picture a tree in a peaceful meadow. From day to day, it looks the same branches, the same leaves, the same quiet silhouette against the sky. But over years and decades, its shape changes. Branches stretch outward, new rings form in the trunk. The tree grows not in sudden bursts, but in slow, steady patterns. Galaxies behave in a similar way, not over years or decades, but over millions and billions of years. Their arms curl, their stars drift, their shape reshapes itself as gently as mist settling into new forms on a cold morning. Take the Milky Way, for instance. Our galaxy has been evolving for more than 13 billion years. Its spiral arms, those softly glowing lanes of stars aren't frozen in place. They slowly wind, stretch, and rearrange, like brushstrokes being gently pulled across the canvas of space. New stars are born from great clouds of gas. Old stars burn out and fade. Clusters drift apart. Gravity tugs and pulls at everything, creating patterns that shift so gradually that even if you watch the galaxy for 1,000,000 years, the changes would feel subtle. Andromeda, our nearest large neighbor, is on its own quiet journey. When we look at it now, we see it as it was around 2.5 million years ago, long before early humans roamed Earth. But in its present moment, a moment we cannot see, Andromeda continues drifting toward us, pulled forward by gravity in a slow motion dance that will last billions of years. One day, in the far future, the Milky Way and Andromeda will merge, not in a violent crash, but in a tranquil blending of stars and gas. Most stars will pass by one another without ever touching, because galaxies are mostly empty space. The final result will be a new, larger galaxy, slowly settling into a rounded shape, a cosmic transformation happening so gently that entire civilizations could rise and fall without ever noticing the motion. To put these timescales into perspective, imagine shrinking the lifetime of a typical spiral galaxy into a single day. The birth of the first stars happens just after midnight. The galaxy begins taking shape while dawn is still far away. By sunrise, billions of stars already shine within its disk. By noon, the spiral arms have developed. By afternoon, stars continue forming in clusters, glowing and fading in a rhythm older than language. Human history, in this metaphor, happens not over hours, but in the final fraction of a second before midnight, so brief that it barely registers. Throughout these vast timescales, galaxies also collide, merge, and interact with one another. Sometimes they pass too far apart to change each other much. Other times, they drift close enough that gravity gently pulls out long, delicate streams of stars, like taffy being stretched in slow motion. Entire arms can be reshaped by these encounters, creating tidal tails that span hundreds of thousands of light years. Yet even these dramatic events unfold so gradually that you could watch for 1,000 lifetimes and still see only the beginning of the change. Another way galaxies change is through the birth and death of stars. In star-forming regions, clouds of gas collapse into brilliant new suns. These areas glow softly in blues and pinks when viewed through telescopes, like watercolor swirls brushing across a dark canvas. Massive stars burn bright and die young, ending in supernova explosions that momentarily outshine entire galaxies. Smaller stars glow calmly for billions of years before fading gently into white dwarfs. Cosmic embers that slowly cool across unimaginable stretches of time. Through all of these processes, the spiraling, the drifting, the merging, the slow birth and death of stars, galaxies live on timescales that make even the age of our species feel like a fleeting thought. And yet, this gentle slowness is part of what makes the universe so calming. Nothing is rushed, nothing is hurried. Everything changes, but only in its own time, across spans so long that they feel almost infinite. When we stand outside at night and look up at the sky, we see galaxies frozen in ancient light. But in reality, They are always moving, always evolving, always reshaping the universe in slow, graceful ways. Their vast lifetimes help us feel the size of the cosmos, not just in distance, but in time. The time required for stars to form, galaxies to merge, structures to drift, and the universe to continue its slow, quiet unfolding. Next, we'll explore the largest of these structures together, the superclusters, and how even vast collections of galaxies become tiny pieces of an even grander cosmic landscape. As we continue expanding our sense of cosmic size, we move from individual galaxies to something far larger, superclusters. These are the vast, softly connected cities of the universe, where thousands of galaxies gather into sprawling formations that stretch across hundreds of millions of light years. If galaxies are houses and clusters are neighborhoods, then superclusters are cities so enormous that even metaphors strain to describe them. Yet we'll explore them gently, imagining their shapes and distances in ways the mind can hold without feeling overwhelmed. To ease into this, imagine standing on a high hill overlooking a quiet city at night. Buildings glow softly in the distance. Farther away, other clusters of lights appear. Whole districts spread across the landscape. Streets and highways connect some areas, while others sit isolated in the darkness. Now imagine that instead of a city, you're looking at the large-scale structure of the universe. Each glowing district is a group of galaxies. Each neighborhood is a cluster of stars. Each street or path is a gravitational thread linking one region to another. That is what a supercluster looks like when we soften it for the imagination. Our home supercluster is called Laniakea, a Hawaiian word meaning immeasurable heavens. It spans roughly 500 million light years. To place that in perspective, imagine shrinking the Milky Way, all 100 to 400 billion stars of it, down to the size of a tiny grain of sand. On that scale, Laniakea becomes a structure as wide as an entire continent. Inside that continent of space are tens of thousands of galaxy grains, each surrounded by its own tiny collection of planets, stars, and clusters. The distances between them feel impossibly vast, yet they all belong to one gently connected region of the cosmic web. Another way to picture a supercluster is to imagine several bustling cities scattered across a quiet desert at night. Each city is bright, full of lights. Between the cities lie long stretches of sparsely populated land, where only a few points of light appear. Superclusters form in a similar pattern, bright regions of galaxies clustered together, connected by thin filaments, surrounded by immense cosmic deserts containing almost nothing. These deserts, or voids, can be so large that if the Milky Way were a single glowing marble, the void might stretch as wide as a country. Superclusters also help us understand just how small our galaxy is in the grand scheme of things. Earlier, we compared the Milky Way and Andromeda to glowing plates on a dark beach. A supercluster, in comparison, would be an entire coastline filled with plates, thousands of them stretching from horizon to horizon. Even then, that coastline would be only a tiny part of a much larger continent of cosmic structure. Despite their massive size, superclusters are not tightly held together by gravity in the way smaller clusters are. Instead, they are gently organized by the underlying dark matter filaments of the cosmic web. Some galaxies in a supercluster may never interact, never drift toward one another, never merge or collide. They simply share the same overall region, connected more by the shape of space-time than by direct gravitational pull. It's like living in the same country as someone you will never meet. Your paths are shaped by the same landscape, even if the two of you remain forever far apart. To visualize superclusters more softly, imagine a vast bowl of soap bubbles resting in the dark. Each bubble touches others at certain points, while large pockets of emptiness lie between clusters of bubbles. Now imagine that each bubble is filled with galaxies. Some bubbles cluster tightly, others drift loosely. Some cling together at delicate edges. The foam-like structure resembles the way superclusters gather into sheets and walls across the universe. The most famous of these colossal structures include the Sloan Great Wall, the Hercules Corona Borealis Great Wall, and the Shapley Supercluster, gargantuan formations so enormous that they stretch across billions of light years. If we shrank the Milky Way down to the size of a single grain of sand again, one of these walls would be larger than entire oceans. These are among the largest structures ever observed, pushing the limits of what the laws of physics allow. Yet even these immense structures are only small pieces of a larger whole. Threads woven into the cosmic web that spreads outward in every direction. And beyond the web, the universe continues to expand, carrying even the largest superclusters gently apart over time. As we drift forward, we'll step back even further for a final perspective, one where the entire universe becomes a single, softly glowing structure, and the concept of size becomes something closer to a feeling than a number. As we arrive at the final stretch of our journey, we step back farther than ever before, far enough that every structure we've explored begins to blur into something unified and softly glowing. We've moved from planets to stars, stars to galaxies, galaxies to clusters, clusters to superclusters, and finally to the colossal threads of the cosmic web. But now, instead of zooming into any one detail, we let it all merge into a single, tranquil image, the universe as a whole. Inside, tiny flecks shimmer when you turn it gently. From up close, each flake looks distinct, but when you hold the globe at arm's length, those flecks blend into a single quiet scene, still beautiful, but no longer defined by individual pieces. The universe behaves similarly. Up close, galaxies stand out as brilliant spirals and glowing ellipses. But from far enough away, conceptually, since no vantage point like this actually exists, the universe becomes a faint, lacy texture made of countless islands of light, connected by invisible threads. To soften this image further, picture the cosmic web we discussed earlier, its glowing filaments and vast dark voids, as a quiet forest seen from above. The tallest trees stand like bright clusters. The winding paths of lower undergrowth resemble filaments, and the patches of empty clearing mimic the enormous cosmic voids. Viewed up close, each tree and path is unique, but from far enough away, the entire forest becomes a single continuous pattern, a living landscape. Now imagine stepping back even farther. The forest becomes a shape. The shape becomes a pattern. And eventually, at an unimaginable scale, the universe becomes a faint, delicate haze of structure spread across an ocean of space-time. Not a picture with edges, not a sphere floating in darkness, just a boundless space filled with gentle, uneven texture, glowing here, quiet there, expanding everywhere. In this perspective, our observable universe, the 93 billion light-year sphere we discussed earlier, becomes only one region within a far larger whole. Like a candle's glow in a vast night, it illuminates only the space that its light can reach. Beyond that glow, the universe continues quietly, potentially without limit. If our observable sphere were the size of a single bubble in a bath, the full universe might be the entire surface of the tub, or the whole room, or something far larger still. We do not yet know. The size may be finite or infinite, measurable or immeasurable, but whatever its true scale, the part we can observe is almost certainly only a fraction. And yet, this isn't a thought meant to overwhelm. It's a reminder of perspective, a quiet reassurance that the cosmos is vast enough to hold everything, including our tiny place within it. Our planet becomes a grain of dust. Our solar system becomes a whisper. Our galaxy becomes a faint smudge of light. And our lives, with all their worries and stresses, become even smaller. But this smallness is not insignificance. It is peaceful, humbling, soothing, a soft exhale into the fact that the universe has been unfolding for billions of years before us and will continue unfolding long after, with no rush, no pressure, no urgency. In this gentle view, the size of the universe becomes less about numbers and more about feeling. A feeling of spaciousness, a feeling of drift, a feeling of being part of something impossibly large and incredibly calm. There is no edge to bump into, no boundary to fear, just endless quiet expanses in every direction, stretching out like an ocean at night. And within that vastness, our tiny corner becomes something precious, a flicker of warmth in a cosmic sea, a small point where consciousness briefly woke up, looked around, and wondered about the stars. As we hold this final image, we let the enormity soften into comfort. The universe is immense, yes, far beyond what our minds can fully imagine. But sometimes, letting go of the details and simply feeling the scale is enough. A gentle reminder that we are drifting in something ancient and beautiful, part of a story that spans all of time and space. When you're ready, we can bring this long journey to a peaceful close. Just let the size of the universe settle quietly around you, like a soft night sky. If your eyes are heavy now, or your thoughts are floating gently, that's perfectly all right. Tonight, we wandered through distances so vast they almost slip beyond words. From planets to galaxies, from clusters to the cosmic web, all the way to the quiet possibility of the infinite. And through it all, you simply drifted, calmly, slowly, without needing to understand every detail. If you enjoy these quiet nighttime explorations, you're welcome to subscribe for more calm journeys like this. It helps this space grow and gently reach others who might need a peaceful guide into sleep. But for now, there's absolutely nothing you need to do. Just breathe. Let your thoughts dissolve into the softness of the night. Let the immensity of the universe cradle you, not as something overwhelming, but as something serene and spacious. Thank you for spending this time with me. Rest well.